Okay, so this video is your study guide for Math 4 functions test. So what I've done is right before we take a test, I make a study guide that is pretty much exactly like the test will be set up, just different numbers. So as long as you're going through the study guide and you're actually trying to figure out how to do the problems and you're following along, you should be fine on the actual test. But we'll see. Okay. So the first thing we looked at was, the first thing we're going to look at is evaluating functions. So if you remember, when you evaluate a function, that's when you actually calculate it. So when it says f of 9, remember it usually looks like f of x. So what it's telling you to do is replace the x with 9. So that's what I'm going to do. So everywhere I see an x, I'm going to write a 9. I'm going to do the top first, so I get 7. I'm going to do the bottom next. I get 21. And if I reduce that, you can put that in your TI-84 calculator, hit math enter. You get 1/3. Okay, so for the next one, it's pretty similar, except this time you're not replacing x with a number, you're replacing x with x minus 1. So everywhere I see an x, I'm going to write x minus 1. And I'm going to keep that in parentheses because I want to remember that it goes together. Alright, so everywhere there was an x, I replaced it with an x minus 1. And now I'm just going to start to simplify. So on the top, the only two like terms are the -1 and the -2. So that becomes x minus 3. On the bottom, I have to distribute anytime there's a number in front of a parenthesis. So this is what I get. And then the only two like terms are -2 and 3. So this becomes 2x plus 1. You can't simplify any further, so that's your final answer. Okay, then 3 and 4 are pretty similar. We're going to replace x with 2x minus 1. So everywhere I see an x, I'm going to do parentheses 2x minus 1. Alright, and the only tricky part here is on that last set of parentheses, when I have it squared, that means write it twice. So this is what you're doing. Alright, so the first part's pretty easy. All I have to do is distribute. Oh, try that again, Miss Lee. So 6x minus 3. The second part, I'm going to subtract the quantity I get. So I'm going to have to FOIL 2x minus 1 and 2x minus 1 together. So you are in Math 4. I'm going to assume that you can FOIL by now. If not, that's a big problem and you need to tell somebody. So now I have to distribute this negative to everything in the parentheses. I have run out of room. Sorry about this. So when I distribute it, this is what I get. Alright? And then I'm going to get my like terms together. So my final answer is going to be -4x squared plus 10x minus 4. If you need further information, you can send me a message. Number 4, anytime I see the x, I'm going to replace it with parentheses -3x. -3x squared. Okay, so this is when I'm going to do pretty much the same thing. I'm going to write this parentheses twice. So the first one, all I have to do is distribute. 3 times -3 is -9x. I'm going to distribute that negative in just a minute, but I'm going to go ahead and do the two parentheses together. So a -3 times a -3 is a positive 9. X times x is x squared. So now when I distribute that negative, I get -9x minus 9x squared. Technically, that's not in standard form. Remember, the part with the biggest exponent goes first, and then the next part. Alright. So now we're going to do the very last two, 5 and 6. Okay. Oh, can't stand looking at all that mess, sorry. Alright. So for the first one, I'm doing h of -7. So -7 either goes into the first one or second one. It is less than -3, so I'm going to plug it into here. And so anywhere I see an x, I'm going to replace it with -7. Alright, so negative 4 times negative 7 is positive 28. 28 plus 7 is 35. And the absolute value of 35 is 35. So my answer is 35. Okay, for number 6, x is now negative 3. That falls into this category because it has that little bar, which means it can be equal to. So I'm going to plug in negative 3 anywhere I see an x. And I'm going to keep it in parentheses. And you can type all of this into a calculator. Even in the Desmos calculator, you should get 45. So that's how you do those. Alright, we also looked at parent functions, transformations, and graphing. You can look back at the notes, look at all the rules while you're doing this. I'm just going to do it pretty quickly. So if the quadratic parent function, so remember the parent function would look like x squared. That's your parent function. If it's reflected in the y-axis, that means you would have a negative in front of here. It's compressed by a factor of 1/2. It's vertically compressed, so it goes in front. That's your new equation. Alright, number 16. If the cube root is the parent function, so it would start out like this. If it's stretched, horizontally stretched by a factor of 4, that means 1/4 goes in front. Then it's translated 5 units to the right, so that's beside, but it has to be inside inside of parentheses. And then if it moves up, that means +3 at the very end. Alright, so if these are not making sense, you need to stop what you're doing right now, go back and watch those videos. Okay, so number 17, the absolute value is your parent function. So you know it looks like this. It creates an absolute maximum at -2, 7. So that means it's moved to the left -2, so +2 inside, and it means it moved up 7. Okay, and then it also had to flip over to get -2, 7. Well, I would also accept this. Okay, so anything that would give me an absolute guess. Okay, I'll just confuse myself. So because it says absolute maximum, that means that this point has to be a maximum, which is why it had to flip over, which is why I put the negative in front. Okay. Alright, number 18. A certain function is vertically stretched by a factor of 2. It doesn't tell you what type of function, so you could really just put anything. I'm just going to use linear, because I think that's easier. So, some linear function was stretched by a factor of 2, which means it went in front, compressed by 1/4. Alright, so we're going to put 4 in the very front, so kind of like, we'll do some parentheses. Just made that so ugly. Alright, and now that I'm looking at this, I hate this question. Sorry, I stole this from somebody else. Okay, so we're going to get rid of that, pretend like it never happened. I will not put that on the test. I promise, promise, promise. Okay. Let's look at number 19. This is pretty easy. This is when we just listed what they did. So if you see numbers, not exponents, just numbers, you got to tell what they do. So that 3, that represents a vertical stretch. And then because it's negative, it also reflects over x-axis. So I'm going to put and reflect x-axis. The 1/2, because it's in front of the x, that's a horizontal stretch by 2. Go back and look at the rules if you don't believe me. And then the +7 at the end, that means moved up 7. Okay, number 20, we're going to describe all of them. So everywhere I see a number, even this negative right here, something happened there. And now I just got to tell what happened. Okay, so the 2/3, that's your vertical compression by 2/3. That negative means you reflected over x-axis. Oh, I'm sorry, y-axis, my bad, because it's inside the radical. Y-axis. The -5 means right 5. And then the 2 up 2. So that's how you do those. So if that doesn't make sense, you're confused, go back and rewatch the videos. Make sure you do this before test time, or it's not going to be good for you. Alright, and then also you need to know how to do key features. So anytime you want to use Desmos on a test, that is totally cool with me. I'm going to just sketch a graph. Yours can be a little more precise. I'm just kind of doing this. Okay, so domain, anything but 4, because it doesn't hit at 4. Also, 4 would make the bottom 0. So my range is going to be y is anything but 1, because it just is. I'm going to say anything but -1, because if I had drawn a better graph, that line actually never touches -1. Here, let me do a better graph. It gets really close to it, but it doesn't go through it. That's why I can never be -1. My x-intercept, if you do it on Desmos, it looks better, 7, 0. My y-intercept is 0, -1.75. I don't see any extrema. It's never increasing. It decreases from -infinity to 4, and then from 4 to infinity. Because remember, it can't be 4. All right, and we're not going to worry about in behavior because I don't care. Okay, so let's look at 24, piecewise functions. So if I wanted to identify the domain and range, I just got to pay attention to where the open circles are. So the only place that x can exist is right here, because you have open circles, and that's at -3, so x cannot be -3. And then you also have this weird asymptote, so the graph never hits 5 as well. The range is everything, -infinity to infinity. You're good on range, everything's covered, and discontinuities. So at x equals -3, there's a jump going on. At x equals 2, you have a jump going on. And at x equals 5, you have an asymptote. So those are your discontinuities. So right here, so you got the jump. You got a jump right here, and then an asymptote. Alright, so for the next one, domain is actually -infinity to infinity, because everything's covered. The range is anything less than 6. So I would say -infinity to 6. And discontinuities, you definitely have a jump right here at -2. And then you have a jump right here at 1. So those are some holes or breaks in the graphs. Okay. So for 26, we're going to graph the function below, identify the domain and range, state the location and types of discontinuities. So remember, this is when you'll make those 3 different tables. So I'm going to pause the video and make the tables really quickly. Okay, so here's your tables. I used my calculator. Notice at this point, I left it open because it doesn't actually equal. At the -4 and the 1, those are closed in circles because they can be equal to. And at the 1, 3, that is an open circle because it's not equal to 1. If you're having trouble with this, once again, go back and watch the video. So, for this one, and actually, let me change this a little bit. This should actually look like this. 1, 1. Sorry, this should be a -1. Okay, The domain is covered, so negative infinity to infinity. The y value, the highest it ever gets to, let's see, the lowest it ever gets to is -4. So from -4 to infinity. And discontinuities, you definitely have something going on at -4, a jump, and you have something going on at 1, a jump. Alright, let's look at our composition of functions. Okay, so the first function is the one that goes on the outside, and the second one goes on the inside. So I'm going to write the h function. It looked like this. I'm going to replace x with the f function. This is how we did it in the notes. You can go back and watch if you need to. I'm going to distribute the 3. And then I'm going to get my like terms together, but luckily for me, they're already together, so this is what you get. Alright, and then if you needed to state the domain is from negative infinity to infinity. Alright, for the second one, f is my first function, g is my second. So I'm going to put my g inside my f. So here's my f function. And everywhere I see an x, I'm going to write the g equation. Alright, so luckily for me, anytime you have a radical and a square, they cancel out. So I'm left with this. Alright, and then I can distribute this negative. So negative x minus 7 minus 2 x plus 7. And that's it. My domain is going to be, let's see, it's going to be -7 to infinity. Alright, and then the last one, f is the first one, h is the second one. So h is going inside of f. Here's my f function. Everywhere I see an x, I'm going to write the h function. So remember, anytime you have a parenthesis squared, that means to write it twice. After I write it twice, I'm going to FOIL it. Then I'm going to have to distribute that negative to everything. Minus 1. I'm going to have to distribute that -2 to everything. And then I'm going to get my like terms together. So I end up -9x squared plus 1. And this has a domain of all real numbers. I know I'm going really fast. That's because we've already done this in class. You have all these resources to go back and look at. So as long as you're putting in the time, you're going to be fine. We also did regression, and you could either do this using a Desmos calculator, or you could do it using just a regular handheld TI-80, blah, blah, blah. Okay, so 44, I'm coming up with a cubic equation. So I don't know if you're using Desmos or if you're using a calculator, but you can go back and look at those videos if you don't remember. I'm going to do this really quickly. And I'm just going to round to 2 decimal places. Alright, so that's the answer you should get. And then you can always go back and rewatch the videos to get the steps back in your head before you take the test. Alright, so the number 45 says use a cubic function to estimate the value of y when x equals -8. So we're going to stop right there. So we'll make a cubic function first. Alright, and now I'm going to use that function, use my table, and I'm going to figure out when x is -8, y is 3,131.2. Now the question asks, how does the estimate change when a quartic function is used? So now I'm going to have to make a quartic function. And now using that quartic function, when I look at the table, when x is -8, y is now 3,412. So it increased, however you want to say that. Okay, so good luck on your test. You can kind of see what kind of questions are going to be on it. I expect you not to cheat on the test, but you have all these resources to go back and look at before you take the actual test. There's really no reason not to pass, but if you're going to be lazy, you may not pass. Okay, do with that information what you will. Let me know if you have any questions.